Welcome to the Podkey summary of Migrate to Swift testing from WWDC 2026. Swift testing is getting a lot more practical, especially for teams that still have a pile of XCTest around. The big story here is interoperability. You can mix the two frameworks, control how loudly cross-framework problems get reported, and migrate bit by bit instead of stopping everything for a giant rewrite. On top of that, Swift testing brings some very useful quality-of-life upgrades, like parameterized tests, exit tests for crash paths, and cleaner ways to skip or stop tests. Xcode gives you 4 interoperability modes between XCTest and Swift testing: limited, complete, strict, and none. Those modes decide what happens when code from one framework causes an issue inside the other. In limited mode, XCTest-originated issues show up as warnings. In complete mode, that same issue becomes an error. And in strict mode, it becomes a fatal error that stops execution entirely. So this is not a cosmetic setting. It changes whether a problem is easy to miss, impossible to ignore, or severe enough to halt the run right there. A very concrete example is when a Swift testing test calls an old XCTest helper, and that helper uses XCTfail. That failure gets reported as a cross-framework issue, and the selected interoperability mode decides how serious it looks. If your test plan is set to limited, you can end up with a warning and a passing test, which is the kind of thing that makes people squint at CI and mutter. Flip that same setting to complete, and now the exact same problem fails the test as an error. That makes missed bugs much more visible, especially during a gradual migration where old helpers are still everywhere. The migration story is refreshingly sane. You can add Swift testing tests alongside an existing XCTest suite and only migrate tests when you're already touching them. That means no all-at-once conversion project, no dramatic freeze, and a lot less risk. There is one structural rule to keep in mind. Swift testing tests can't live inside XCTest classes. So new Swift testing cases go in separate files or at the end of existing files, while the old XCTest code stays where it is. It's a coexistence model, which is usually what real codebases need. One of the nicest Swift testing features here is parameterized tests. Instead of writing loops inside a single test and then digging around when one case fails, Swift testing creates a distinct test case for each argument combination. Those cases also run in parallel, which can cut execution time pretty dramatically. And in the test navigator, you can see each combination listed individually. So if a specific input pair is the one that blows up, you know exactly which one it was, instead of reverse engineering a for loop after the fact. That's one of those changes that sounds small until you've had to debug the old version a few times. Exit tests are another big one. They run the test body in a child process, which means you can exercise code that triggers a precondition failure or a crash without killing the whole test run. That opens up coverage for code paths that were often left untested, simply because testing them was too destructive. By using #expect with an expected failure exit status, those crash cases can become intentional passing tests. So code that used to be basically off limits for coverage can now turn green, which is nice, both for confidence and for the coverage report. People like to stare at. If you're modernizing shared helpers, there's a good replacement for XCTfail in Swift testing: issue.record. It gives you that same unconditional failure behavior, but it plugs into Swift testing's reporting model properly. And if you pass source location, you can preserve accurate file and line information. That matters, because helper functions are only helpful when they point back to the real call site, instead of making you hunt around. Updating helpers this way also keeps reporting more consistent across Swift testing and any XCTest test you still have hanging around. Swift testing also changes the feel of test control a bit. For skipping, it uses traits like enabled and disabled annotations, instead of putting XCT skip logic inside the test body. That makes test suites more declarative, because the enablement rule lives with the test definition, instead of being buried in the middle of execution logic. And for stopping a test early, #require is the important piece. If #require fails, it throws and halts the test automatically. So you don't need the old XCTest pattern of setting continue after failure to false. You can mix #require and #expect depending on whether a failure should stop the test or let it keep going, which gives you much more precise control. One subtle detail is that the Swift Package Tools version affects the default interoperability mode. Packages using Swift Tools version 6.4 or newer default to complete mode. Packages on 6.3 default to limited mode instead. So two projects can behave differently before anyone explicitly changes a setting, which is worth knowing if a test suddenly starts failing in one place and only warning in another. If you need to override the behavior at runtime, there's also an environment variable, Swift_testing, XCTest interop mode. That gives teams some flexibility without having to change the package manifest just to experiment or adjust CI behavior. The other piece of context here is governance. Swift testing is open source under the Swiftlang GitHub organization, and development is overseen by the testing workgroup. There are regular community meetings, and new features go through Swift evolution proposals. The recent interoperability support came through that process too, so this is not a black box feature drop from nowhere. If teams care about where testing in Swift is headed, the Swift forums are part of that story, not just a comment section off to the side. Taken together, this all makes Swift testing feel less like a clean slate ideal, and more like something you can actually adopt in a living codebase. You can migrate gradually, get better visibility into failures, and pick up some genuinely useful testing tools along the way. For a topic as glamorous as test infrastructure, that's a pretty solid upgrade. This episode was generated by Podkey. Create your own at podkey.fm.